Okay, so today we are going to talk about UART program in MSP 430 F5529. So before going to the program, I would like to discuss with you all the flowchart or the algorithm that you can use so that you will remember what steps you have to perform in order to write a program for the UART module. So these steps are the same for sending as well as receiving. There will be a minor difference in the sending and receiving programs that we will cover in this lecture. So first of all, if you look at the algorithm, this is the algo section. Very simple. First is you have to select the pins for the UART module that you are going to use. Second would be to configure the UART. Now in configuration UART, I have outlined some steps. That is, firstly you have to disable the UART, then you have to select the clock source, then you have to select the divider, you have to select modulation, and then you have to enable UART, and then you have to finally send or receive data, whatever you are doing in your main program. So I will explain each of these steps as we go through the program. So basically in this program we are going to transmit a data, that is a character A, and we are transmitting it continuously, as we discussed in the previous lecture how the data frame of UART looks like. So, and we also transmitted capital A and explained in that how the data frame looks when you are transmitting a character A with one stop bit, one start bit, no parity bits. So we are going to do the same thing in this program. So what I have done is I have created a function here, UART init. So this function is taking care of these first 2 points, that is selecting the pins of UART and configuration of UART. So if you see, the first point in this is P3SEL or equal bit 3 or bit 4. Now P3.3 is for TXT and P3.4 is for RXT. You can check in the MSP 430 pin diagram here. If you look at the pin number 40 and 41, you will see P3.3 is multiplexed with UCA0 TXT, and pin number 41 P3.4 is multiplexed with UCA0 RXT. So these are the two TXT and RXT pins that we will use in UART. Obviously here we are using the USCI A0 module, that is why it is UCA0, UCA0 RXT and UCA0 TXT. So as we saw that P3.3 and P3.4 are TXT and RXT respectively, and they are multiplexed with the P3.3 and P3.4 pins, GPIOs. So that is why we are using P3SEL for the multiplex function. So using this instruction, we will be choosing these two pins for TXT and RXT and not as GPIO. Now the second point is to configure UART. In that, the first step is disabling the UART. This is important. So whenever we are configuring the UART, we are first going to disable the UART, that is, the UART will not be in use. We can do this using the control register UCA0 CTL1. Again, we are using the UCA0 module, that is why it is UCA0. Control register is CTL1. Like you have studied the timer registers, capture compare registers, ADC registers, it's in the same way you have UCA0 CTL1. The bit that will disable the UART is UCSWRST. So this bit is going to disable your UART. Second step in configuration is selecting the clock source. For this, again we have same register, control register, and we have the bits UCSSEL underscore 2. This selects SMCLK as the clock source. So that means we are having 1 megahertz clock source that we will be using in our UART program. Next step is selecting the divider. Now, as we have seen in the previous section while we were studying UART, there are certain baud rates that are used while implementing UART protocol. So in this program we are going to use 9600 BPS. This is one of the most common and standard baud rates or bit rates that are used in UART. So now since we are using SMCLK as 1 megahertz, we need to come down to 9600 BPS. For that we obviously require a divider. So which divider are we going to use? If you do some basic mathematical calculations, you will see that if I divide 1 megahertz by approximately 104.166, I will get 9600. You can do that calculation yourself. So thus to get 9600, I need to divide my selected clock by 104.166. So this is my divider. Obviously I cannot take the points here because this divider is also stored in a register that is called UCA0 BR0. So whatever divider is there, you have to specify it in a register, as you can see in this step. UCA0 BR0 is equal to 104. Another register is UCA0 BR1. Now both these registers are 8-bit registers. So if you have a divider that is greater than 255 or FF, then you will have to use the second register also. But since in this case we have a divider of 104 only, that is why we are using only UCA0 BR0. So these two registers are used for selecting divider. Now one more thing is, we are missing this 0.166. We cannot store this 0.166 in these registers because these are registers. You can only store integer values here. So for this 0.166, we are going to use a modulation setting. We don't have to go in detail, but what you can understand is, for implementing this 0.166 as close as possible to 104.166, we are going to use this step, the modulation setting, that is UCA0 MCTL, this is another register, equal to UCBR S1. As you can see in the comment here, it is set modulation. Finally, if you can see, we have done all these steps till select modulation, and now finally we are again going to enable the UART. So this will be again done with the same. See, it's the same step. If you look at this step, UCA0 CTL1, since disabling was done through or equal UCSW RST, enabling will be done through obviously the opposite, that is and equal negation UCSW RST. So this will initialize your USCI or UART module again. So we are done with all these configuration steps. Again we can go through them once more. Disabling UART, selecting clock source, selecting the divider, modulation, and finally enabling the UART again. So this configuration has to be done in all types of UART programs, whether you are sending, whether you are receiving. Only thing that might change is the data rate. Whatever data rate is there, you have to select the divider accordingly. And as I have explained here, how you are going to select it.